evening everyone. I am Incent Rene Morata from BSEE and today I am going to present my summary of Module 8. Enjoy! First, what is a CPU? The Central Processing Unit, or the CPU, is an electronic hardware that executes computer program instructions. It is mainly the brain of a computer, and it does exactly what we tell them to do. So, it is also constantly following instructions of computer programs that tell it which data to process and how to process it. Without a CPU, we could not run programs on a computer. The evolution of computers. So as you can see in the picture on the left, it is the ENIAC, or the first programmable computer that we had. ENIAC stands for Electronic Numerical Integrator and Computer. So ENIAC is very big. It occupies almost 15 by 9 meters, and it is composed of 40 panels, and those 40 panels is also composed of many capacitors, switches, and resistors. So that explains why it is very big. On the other hand, you can see a laptop on the right side picture, and it is one of our latest technologies that we made, and compared to the ENIAC that occupies a basement back in the World War II, we can now use computers just right over our lap. And how did that happen? And let me explain that with the Moore's Law. Moore's Law states that the number of transistors on a microchip doubles about every 2 years, though the cost of computers is half. So he quoted that, frankly, I didn't expect it to be so precise. So Gordon E. Moore, in 1965, he is a co-founder of Intel, made his observation that he became known as Moore's Law. We also discussed about von Neumann architecture. So it is based on the stored program computer concept, where instruction data and program data are stored in the same memory. This design is still used in most common computers produced today. So it has an input device with a single bus going to the CPU that has the control unit and ALU, or arithmetic logic unit. And it connects with two buses, connecting from CPU to memory unit, and from CPU it connects to the output device. Von Neumann architecture is comprised of 4 stages: the fetch stage, the code stage, execution stage, and write-back stage. And these 4 stages is called the pipeline. And to measure the depth of the pipeline, these stages is also divided into smaller operations, which is also called UOPs, or micro operations. Front end, where the program predicts what route the data would get in order to execute the program. Data speculation was created in order to make the program run more efficiently. So the front end is the part of the pipeline where it is on the fetch and decoding stage, while the back end, it is the part of the pipeline where the execution and the write back is being processed. So superscalar execution, adding more cores in the CPU so that more ALUs will be used in the program. It also increases the demand in the front end. So using superscalar execution, or adding more ALUs, will determine the width of your microarchitecture, or the pipeline. And the other one used in order for your microarchitecture or your program to run efficiently is to use the out-of-order execution, because program works without following the order to remove unnecessary time needed for the data to process. And this ends my presentation, and you for watching. Have a great day.